Guys, we are going to combine lessons 3 and 4 in the book. So we're going to talk about the reciprocal functions of sine and cosine, which is cosecant graph and secant graph. We're also going to talk about tangent and cotangent. So cosecant is, like I said, it's the reciprocal of sine. So what we're going to do with cosecant is we're going to bounce off the sine graph. And with secant, we're going to bounce off the cosine graph. So this is not going to affect the time period of our just original parent functions. And as I've said before, none of these graphs that we're going to talk about today are going to have any amplitude. So that is going to remain consistent. Amplitude only happens with sine and cosine. We're going to talk about domain and range later because it's going to really be switched up. So when you start with your XY chart, just start like you would any sine graph. And you are going to treat whatever this looks like, whatever the graph looks like, you are going to treat that just like you're graphing a sine function. Okay, so your sine function, the parent function just looks like this. Okay, so from here, to switch it to a cosecant, what we're going to do is we're going to find the dots at the equilibrium position. So in this case, it's going to be these values. And think about this. If we're finding the reciprocal of these zeros is going to be undefined. So instead of having just a 0, now we're going to have an asymptote there. So every time, and this might be shifted up, so it might not be 0, but at the starting point, wherever those are zeros, it automatically turns into an asymptote. Okay, as we get to 0, so as this graph approaches 0, from going from like 90 to 0, it is going to approach positive infinity. As it goes from 90 to 180, it also approaches positive infinity. I am not going to require you to like specifically plot any of these points. So even though it's not a parabola, this is how you're going to graph. So as soon as you like figure out where it bounces and how it bounces off, you're good to go. Same thing down here. So as we go from 270 to 180, it approaches negative infinity. And as you go from 270 to 360, it approaches negative infinity. So this is the look of a cosecant graph every single time. So no matter what we do to it, how we stretch it and do different things with it, this is how it's going to look every time. Okay, so let's talk about, I think I want to start with range. So notice that our range starts at 1 and goes to positive infinity here, and it goes from negative infinity to negative 1 down here. So that's how I'm going to write my range. Okay, in Unit 3, we really talked about I told you that we were going to really talk about in Unit 4 about like the patterns of when things happen. So notice like we've got an asymptote here, here, and here. So what is that pattern? I'm going from 0 to pi to 2 pi. So if you'll notice, I'm going up by pi every time. Okay, so there's a couple things that I want to say about this. First of all, you can't use interval notation here. That's why I've been kind of keeping that set notation. Even though I prefer interval notation, you cannot use it on secant and cosecant graphs. So first of all, I want to know where it breaks. So it breaks, there's an asymptote, so 0, pi, 2 pi. Okay, so I'm going to say x cannot equal pi. If I use 0, that's not really telling me too much, so I'm going to say pi, and then I'm going to add my pattern. So if I add, like, if n is 0, then my answer is 0. If n is 1, you get the idea. So so at every pi, that equation breaks, but that is my domain. Okay, now we're going to do the same thing. I think that you can set it up. So same process. We're going to bounce off the cosine function. So see what you can do there. Okay, so this is what I have so far. So this is just the graph, my XY values for cosine, and this is my graph. I went ahead and put in the asymptotes, and the asymptotes are kind of be our guide. So I'm going to have this other parabola-looking thing that stretches towards infinity here, and then here I am going to have it approach this 90 degrees or pi over 2, and that's going to approach positive infinity, and this is going to approach positive infinity as I go through, go to 270. Now, this will go on and on forever. So if you graph secant on your graphing calculator, it would look like this. So we are just wanting that specific picture, just like we did with a cosine value, but this is the look of your secant function. Okay, so notice my range, even though it looks different, my range still goes up from 1 and goes from negative infinity to negative 1, but that's not going to change. Okay, in my domain, so let's go down here and really evaluate it. So my first break is at pi over 2. So I'm going to go up here and say, okay, pi over 2 plus, and then I'm going to find that pattern. So I went from pi over 2 to 3 pi over 2. So again, it was pi, so I'm going to say plus pi n. That's my pattern. Okay, so here are two, there's a secant function and a cosecant function with transformations, and we're going to treat it like this is cosine and the other one is sine. So go ahead and graph it and see if you can switch it over to a secant function. Okay, so take a look at what I did for my secant function. Everything should be there. If you didn't get what I got, double check your chart and make sure that all these match up. Okay, so this is everything I have for the graph of the cosecant function. I am going to talk about tangent and cotangent in another video.